Hi, welcome to Help Session. Today we're going to be covering how to visualize trigonometric angles. So going into this video, I'm going to assume you know what the terminal side and the initial side is. Initial side being the x-axis where the terminal side begins, and theta is the angle between the initial side and the terminal side. I'm going to assume you know all that. So when we're visualizing trigonometric angles, I'm gonna put some example angles up here for us to eventually get to. So it'll be 11 pi over 6, let's say 3 pi over 8, oh, I don't know, 12 pi over 20, yeah, that'll work. 12 pi over 20, and let's say 14 pi over some crazy angle, let's say 26. Okay, so how will we visualize this? Well, the first thing is we want to have a visual or a mental image of the coordinate system. So we know that this is the first, second, third, and then the fourth quadrant. Sorry, fourth quadrant. And so first thing we have to know is that this is angle 0. This is pi over 2. This is pi, and this is 3 pi over 2, and this is 2 pi, or 4 pi over 2, which is just I guess divided down into 2 pi over 2, because if you have 4 pi over 2, you just divide 4 by 2 and divide 2 by 2, which is becomes 1, and so it's 2 pi over 1, which is just 2 pi. Okay, and so the way that I normally do this to quickly figure out what quadrant any of these angles would be in is you want to convert these quadrantal angle, I guess, markers, these staple angles on the y and x axis to the same denominator as whatever angle you're trying to find. So let's say 11 pi over 6. Well, we know pi over 2, if to get to the same common denominator, we need to multiply the top and bottom by 3. So this would become 3 pi over 6. So we know this, if we multiply pi over 6, or pi by the top and bottom by 3, or by 6, to get the same common denominator, it'd be 6 pi over 6. And then if we took the bottom here to get to the same common denominator, we multiply the top and bottom by 3, so 9 pi over 6. And then 2 pi, we'd want to multiply the top and bottom by 6, so this would become 12 pi over 6. Okay, and so all we need to do from here is just figure out where 11 pi over 6 would be. Well, we know 11 pi over 6 is going to be more or greater than 9 pi over 6, because 11 is greater than 9, but we know it's going to be less than 12 pi over 6 because 11 is smaller, I guess, smaller than 12. And so we know that this angle is going to be somewhere by here. This is where theta is equal to 11 pi over 6 would be. So let's work with another angle. Let me erase most of this. Okay, let's try 3 pi over 8. Well, we can do this pretty quickly. So what would so 0, obviously they're just going to say 0. And then if we want to get 8 to be the same, or pi over 2 to get the same common denominator as 3 pi over 8, well, we just need to multiply the top and bottom by 4. So this would actually become 4 pi over 8. And so 4 pi over 8 already we can automatically see is greater than 3 pi over 8. So we know that this angle is going to be somewhere by here. This is where theta would be equal to 3 pi over 8. This is 3 pi over 8. And so this is the way that I do it. There's other ways you can do it where you take pi, treat it as 180 degrees. So this would be 3 multiplied by 180 over 8. And so you know that this is going to be, wow, this would be 8. So I fail at mental math. Divided by 8, this is going twice, 16 to 20 twice. Okay, so it doesn't even go in evenly. Normally you can, I guess, you could treat pi as 180 degrees and then just divide it by the bottom and then multiply it by the number that's multiplying pi, and then you can get the actual number of degrees. But I think it's often a little excessive. It's a little too involved for, say, when I'm in a test and I need to quickly just, figure out the angle, just to keep moving on with the problems. So I like this method because once you can sort of I guess quickly do the conversions of pi over 2, pi, 3 pi over 2, and 2 pi into the same denominator as any of these, then it becomes a very simple and normally 100% effective method for figuring out what quadrant the angles are in. And so yeah, that's about all I have for this method. If any of this was unclear, make sure to leave a comment and leave suggestions if you understood what I was saying but I explained it unclearly. So yeah, thanks for watching. See you later.